Okay, this is Advanced Algebra SLO review number 1. Okay, we're going to start with radicals. Okay, this is breaking up radicals and then actually doing an operation with them. So the first thing we got to do is look and see if 18 is a perfect square. Um, if you don't know this, there's several ways to do this. You can put this in your calculator, and if you look over here, you can hit the second key and this key right here. It brings up the square root. And so you put 18. And if it gives you a decimal, it's not a perfect square. So, obvious, I want these broken up using the perfect squares. So, I know this is kind of blurry, but what I wrote was the perfect squares here. So, what we want to do is find the square root of 18 on this number line. And we're using these numbers here because they're the ones with the square root on it. And so, we're not going to find 18 on here, but we need to figure out where 18 would fall. Well, 18 would fall right here between 25 and 16, the square root of 18. So remember, what we do next, I'm going to pull my calculator up. I'm going to move this over so we can see it. We put 18 in, and we're going to work our way up. We're not going to go down. So we're going to do 18 divided by 16. And we're looking for the first one that's going to give me a whole number. So 18 divided by 16 gives me 1.125. So that's not going to work. So we do 18 divided by 9. And we get a match. And that's our biggest one. So okay, so the way we put it in, we put that 9, it was square root of 9, square root of 2, because we take what we put in the calculator. So we did 18 divided by 9, and it gave us 2. So 9 was the perfect square we used. 2 was the answer. So we have them both on these square roots. And then we come here. 9 is equal to 3. So we know 9 is going to be 3 with no house on it. And 2 is not a perfect square, so he stays underneath the square root. Okay, so then we're going to bring down our sign of minus here. And then now we got to break up the square root. Well, before we do that, this was a negative 18. So remember, we can't take the square root of a negative number, but what happens, it changes to an I. So that negative changes to an I, and he comes out in front. So it's 3i square root of 2 for the square root of negative 18. Now we're going to take the square root of 8. So we got to treat this like a number line again. Figure out where the square root of 8 will fall. Well, we know it's in between 4 and 9. So we get our calculator and we do 8 divided by 4 because we always want to go up, not down. And we get 2. So we're going to use square root of 4, square root of 2. And if we look here, the square root of 4 becomes 2. And the square root of 2 stays in the house. The negative changes to an I. Okay, so now your final step is that. Okay, your final step is to subtract if you can. You're only going to subtract if they have the same radicals. And that's just another name of saying square roots. So if you look here, I'm going to bring this out. We got 3i squared 2 minus 2i square root 2. So we see our square roots are the same. So as long as the square roots are the same, all we got to do is do this operation, 3i minus 2i. So 3i minus 2i just gives us an I, or 1i. And then we bring the square root of 2 over. And that will be our final answer. But remember, we can only combine them if the square roots are the same. So let's try another one. Okay, our next example is the square root of negative 150 minus the square root of negative 75. So what we have to do, we have to figure out how to break this up. So we have to put 150 on the number line. And you notice it's not on there. So we go in between 144 and 169. And all we're going to do is divide 150 and we go up. 150 divided by 144. And we're looking for the one that's not going to give us a decimal. So 150 divided by, and guys, it's a good idea to not skip. Please don't skip. So we got a decimal, 150 divided by 100. A lot of people like to skip and they make mistakes. Still got a decimal, so we keep going up. 150 divided by 81. We get a decimal. 150 divided by 64. 64. And we get a decimal. 150 divided by 49. And we should still get a decimal. Then we try 150 divided by 25. Okay? And we get 25 and 6. So we're going to put them both on these square roots. 25 and square root of 6. And we know 25 becomes 5. And the square root of 6 stays there because he cannot break up. Make sure you always put the perfect square first. And then the negative becomes an I. Okay? So now we're going to break up the square root of 75. Okay? So 75 is not on here, but it falls between 81 and 64. So if we break up the square root of 75, we do 75, and remember we always go above it. 75 divided by 64, and we get a decimal. 75 divided by 49, and we get a decimal. 75 divided by 36, and we should get a decimal. 75 divided by 25, and we get 25 and 3. So that was minus 25 and 3. 25 becomes 5i and square root of 3. So on this example, we're looking to see if we can combine them to subtract them. So if you look, and I just threw this example in here, we got different square roots, so we cannot combine them. And this will be our final answer. So I just want to throw that one in for you. So if they had the same square roots, let's just change it so you can see it. If it was 5i minus, and let's change this a little bit. Say this was 6i square root of 3. Square root of 6. We can combine it. So same radicals. All we do is do the operation in front. 5 minus 6i gives us negative I square root of 6. And so that will be it. So what you would need to do now is to work these other problems here, B, C, and D. So pause the video and work those. Okay, so number 2, it says, is the following a factor, yes or no? So we're going to use the easy one, which is the synthetic division. And it says x to the third plus 9x to the second plus 23x plus 15. Then it has a semicolon, x plus 5. So all we have to do, remember, is we're basically setting this one equal to 0, x plus 5 equals 0, and we're solving for x. And we subtract 5 from both sides. X equals negative 5. You can do it this way, or the easiest way is just to change that sign here. So what we do, we put negative 5 here, and once I start doing this, y'all gonna remember, we put our long L. So what we want to do next is to double check and make sure the biggest exponent is in front and all the remaining exponents are there. So if I look, I see 3 is the biggest. So 2 should come next, and then a 1, and then 0. So they're all there. So all I'm going to do, I need the coefficients. And remember, coefficients are the number in front of the letters. So I don't actually want the letters. So if I go back here, what's in front of x to the third? Well, I don't see anything. So if I don't see anything, it's understood to be a 1. Okay, in front of this x squared is a positive 9. And positive 20x is 23x. And then 15 is by itself. Okay? So now all we do is bring down. So we bring down the 1. Now we're going to multiply. So 1 times negative 5. So we bring down, multiply. So drop, multiply. So 1 times negative 5, and it goes here in the next one, negative 5. So, and then we're going to drop it down. We're going to drop our answer. 9 minus 5 gives us a 4. So now multiply. 4 times negative 5, we get negative 20. Okay, we're going to drop our answer down. So 23 minus 20 gives us 3. Now, 3 times negative 5, because we got to multiply, we get negative 15. And we're going to drop our answer. 15 minus 15 is 0. So, if our last answer here, and guys, make sure you finish all the way to the end. I know when we were doing this, a lot of y'all forgot to carry out and make it a 0. So, if it's a 0 here, yes, it is a factor. Yes, it's a factor. Because there's no remainder. No remainder. Okay, let's try another one. And remember, synthetic division only works if oh Lord, wait a minute. If it's x plus something or x minus something. But if it's like a number in front of that x that you're dividing by, it won't work. Okay, so I'm going to try B. Just another one for y'all to go by. So I'm going to do the easy route. I'm going to change this. I know it should be positive 3. So we got 3 here, and then we're going to have our long L. Okay? So now I need to look at my exponents. So I got 3, 2, 1, 0. It's good. So all I now need is my coefficient in front. So I know if it helps you to put a 1 in front, go ahead and put the 1 in front. So 1 in front of this x squared is a negative 1. So guys, make sure you remember you got to put signs. If it's a negative, you got to put a negative. So in front of this x is negative 14. Okay, and then the last one is a positive 25. Okay, so we're going to drop our first one. Drop 1. 1 times 3 is 3. And I don't know if it helps you to put a plus sign. It's a positive 3. So negative 1 plus 3 gives us a positive 2. 2 times 3 is a positive 6. Negative 14 plus 6 is 8. And I guess I could have showed y'all how to actually put these in your calculator. Like negative 14 plus 6. And that gives us a negative, and I didn't write my negative. I'm glad I redid it. Yeah, negative 8. I think I said that, but I didn't do it. So now we put in our calculator negative 8 times 3. And we get negative 24 because we multiplied our negative 8 times 3, negative 24. And then we just subtract. I don't need the calculator, but I'm just showing you in here. Minus 24. We get a 1. So we look, now we don't have any more numbers. Our last number is a 1. So is it a 0? No. So it is not a factor because, and let me make sure what was the, I don't think, no, because it has a remainder. So no, because it has a remainder, or no, because it's not 0. Okay? So you will complete the rest of these. So pause it, and then you'll complete the other 2. Okay? So now we're going to our next problems. So our next problems are what we have been doing. So if we look, it says we have 3 problems. It says, what is the inverse of log 7x? So remember, when we do this, this is really easy. We do log 7x equals y. And then we do our loopy-loop. 7y. And then we loopy-loop over the equals x. Okay? But because it's the inverse, we got to switch it, and that becomes 7x equals y. And so that will be our inverse, basically 7x. It's going to equal y. Well, if you look at some of the choices, this doesn't go with this one, but they gave me f of -1. That's just a fancy way of saying the inverse, or y, the inverse. Okay? So that's the way your answer is going to be you're mainly looking for this part here. Okay? So go ahead and do B and C. You should know how to do those. So go ahead and pause the video and do those. Okay? So let's go to 31. This one is basically looking at a normal distribution graph, and you're finding the mean and the standard deviation. So when doing this, all you want to do is find the mean first, the easiest thing possible. The mean is always in the center. And if you didn't know that was the center, just say you didn't know. Look, we got 1 on this side, 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 1 on this side. This one's in the middle. Okay, so you can see I got 3 on the right and 3 on the left. So the mean is obvious, 16.1. Now the standard deviation is how far is each number from the mean. So I'm going to erase these little tick marks here. So I just pick my calculator up, and I take my number here and subtract them. So I'm going to put 18.5 minus 16.1. And I see it's a difference of 2.4. So let's see if it stays that way. So we'll know for sure that's our standard deviation. We go here, and we're going to do 20.9 minus 18.5. And I get a difference of 2.4. So if you look here, my mean is 16.1. And then my standard deviation is 2.4. Okay? So I'll try B. B, we want our mean, so it has to be in the middle. Make sure 3 on the right, 1, 2, 3, 3 on the left. And then, so 14 is our mean. And then now we got to figure out the standard deviation. We got to figure out how far is each number from the mean. So what we do, we get our calculators, and all we're going to do is subtract. So we subtract 14.5, 14.5 minus 14, and we get a difference of 0.5. So let's try, the next number was 15. minus 14.5, and we should still get a difference of 0.5. Okay, so we got a standard deviation of 0.5. So I want you to try the rest of them. Pause the video and then try the rest. Okay, so the next one we're talking about rewriting logs and solving. It gave you a little side note here. It says, remember, if no base is shown, assume it is a base of 10. That's the common log. So if it helps you to write 10 here, some people it does. And then remember, we're going to do our little loopy-loop. So first, I'm going to give us a problem. So you will have to write this on your webquest, because I actually didn't do this one. We got 9x plus 91 equals 2. So I'm going to plug in my 10. This is going to be 10 to the second. Then we're going to go over the equal sign. So I'm going to put my equal sign equals this whole parentheses. 9x plus 91. So I draw my line through the equals, and I don't know which way y'all can see this. So what I'm going to do is do 10 squared. And that gives me 100. Equals 9x plus 91. Then it's just basically solving for x. Getting x by itself. So all we have to do now is move the 91. So there's a plus 91. So we got to subtract 91 from both sides. So when we subtract 100 minus 91, we should get 9. Okay, so 9 equals 9x, and then divide by 9 on both sides. We know this one cancels out. 9 divided by 9, x equals 1. So all you do is the loopy-loop, 10 to the second. You got to actually tell me what that is. That's 100 equals loopy-loop over 9x plus 91. And then you're solving for x, getting x by itself. So pause the video and work those three. Okay, so the next one, we are dividing imaginary numbers. And these are so easy because all we have to do is just plug them in our calculator. So here's our first one here. And it gave us some extra choices. So in order to put these in our calculator, we must put parentheses around the top and around the bottom. Okay, so we're going to put in our calculators that way. So we do parentheses 3 plus 2. And remember, we need that I. So we hit the second key and this little period. It brings up the I. Close your parentheses. We're going to hit the divide key. Parentheses 4 minus, we need the I again, so second period. Close our parentheses. We hit enter, and it gives us this long little thing here. We don't want that, so we hit math, enter, enter. And it gives us our answer of 10 plus 17 plus 11 over 17i. So you see our answer is not exactly there, but it is there. So all we got to do is look at what numbers they have on top. They got 10 plus 11i. So 10 plus 11i, and then what's on bottom? 17. So our answer is B. So just remember, the key thing is to hit math, enter, enter. Make sure you use parentheses around the top and the bottom. So go ahead and try the next ones. Pause this video, work the next one. Okay, so the next problems here deal with multiplication, and they already give it to you with parentheses. So all you gotta do is just plug it into your calculator the way it is. So you do parentheses 6 minus 4 second period, close your parentheses. Let's do another parentheses, 8 plus 2 second I, close your parentheses. And guys, this is a problem I forgot to tell you that I just made up that's not on this paper. So you have to write it and then we hit enter. And it gives us our answer. Our answer to this problem is 56 minus 20i. These are so easy. All you have to do is plug them in your calculator. So try the rest of them. So pause this video and try them. Okay, so the next problem, it says your parents are trying to save enough money to pay for your first year of college. Their bank compounds the interest rate at 9% yearly. If they open the account with $2,600, approximately, how long would it take for them to have a savings of at least $12,000? And it tells us to round to the nearest year. Okay, so first of all we're going to do is plug in what we have. Okay, so we know it's at a 9%. So remember, if we go through this, P is what we start with. That's what we invest. R is that percent that we're going to change to a decimal. N is how's it compounded. Is it compounded yearly? And let me give you some examples for N. So if it's compounded yearly, N is 1. How many years in a year? 1. If it's semi-annually, that's going to be 2. If it's monthly, how many months in a year? Well, there's 12. What if it's quarterly? Well, how many quarters in a dollar? 4. So quarterly is 4. Daily, I think that's our last one. Daily. How many days in a year? 365. So if our N is one of these, this is the number we will use. Okay? So if you look at ours, it says it is compounded. Their bank compounds the interest at 9% yearly. So that means N is 1, and this is our rate here of R, sorry, of 9%. It says they opened their account with $2,600, so that's our P. That's what they started off with. And then it says how long will it take for them to have a savings of $12,000. So this is how much money they want. This is the amount they want in the end. So first of all, what we're going to do, we're going to actually put this in. So A, I want $12,000. That's how much they want. But they want to know how long it's going to take them to get that $12,000. So P, how much did they invest? $2,600. Okay? And move this over some. Then it's going to be 1 plus their rate. It's at a rate of 9%. So let me show you how to change 9% into a decimal. So if you were given 9% or any percent, all you got to do is drop the percent. You put the decimal, and the decimal is always going to be in the back unless they give it to you. But they didn't give it to you, so you move it 2 places to the left. 1, 2. And you see there's no number here, so you got to put a 0. So our percent will be 0.09. Okay? So remember, N tells us how is it compounded. and it said it will compound it yearly, and we said that n is going to be 1. Okay? And so right here we got our n and our t. So n again is 1, and t, well, t is what we don't know. We don't know how many years, because that's what we want to figure out. How many years would it take us to get $12,000 to have enough to pay for our child's first year of college? And that's probably an old estimate of $12,000, because it probably costs a little bit more than that now. Okay, guys, I had to change that problem. It will be changed on your practice test as well. So we're going to do it the simple way. We're not going to do a whole bunch of complicated. So we're going to change the problems. So let's start over. It says your $440 gets 5.8% compounded. Okay, so we're going to start all the way over. So your $440 gets 5.8% compounded annually for 8 years. What will your $440 be worth in 8 years? Okay, so let's first go through. P is what we started with. So we started with $440. So I'm going to try to do this in the same similar step. So P is going to be 440. That's what we started with. I'll put my 1 plus, okay? It gets 5.8%. So we're going to change our decimal. 1, 2, so to be 0.058. So that's going to be my rate, my R. 0.058 over my N. My N tells me how is it compounded. So it's compounded annually. Remember, annually, it means how many years? 1 year. So we put 1 there. And then we got our N times T. So N, once again, is 1. How is it compounded? And then T is the number of years. So it's for 8 years. And so therefore, okay, so now all we have to do is plug this into our calculator. So I'm going to pull this up to show you. I'm going to minimize this one. So we're going to put this in our calculator the way we see it. 440, so 440 parentheses 1 plus 0.058 divided by 1, and then we hit the caret key, and we want these in parentheses. 1 parentheses 8, and then we hit enter. So after 8 years, if we invested only $440, that is compounded annually, mean we get interest once a year at 5.8%. Okay, so A equals 690, and this is what it gave us. But I want you to remember, we're talking about money, and so therefore money goes 2 places after the decimal. So here's where I put my line. If it's 5 or higher, it will make this number go up. So it'll be $690.78. So that is the amount that we will have after 8 years that is compounded annually. Okay, here's one more example just for us to go over it again. It says you invested $1,690 for 5 years at 5.7%, compounded semi-annually. What total will you have after that 5 years? Okay, so we know we started off with P, so it's going to be 1690. Okay, 1 plus, we need our rate. So we got a rate of 5.7. Remember, got to move our decimal place 2 places. So 1, 2. So we'll get 0.057 and that'll be our R. I like to write it out this way so I'll have everything in order, and I usually like to go in order. N is how's it compounded. Semi-annually means N equals 2. So we're going to put that over 2. And then we put N here of 2. And then T is the number of years. So it's at for 5 years. Okay? And so we're going to plug and chug this into our calculator. So we do 1690 parentheses 1 plus 0.057 divided by 2 raised to 2, and then we got 5 over here. We press enter. Okay, so that's 2,238 and 35 cents. So let me write that 2,038. I think it's at 35. It went away. 36, because we got to round up. So 36. So that's how much I'll have at the end of 5 years. So go ahead and pause this video and do the other problems. Okay, so here's the next problem. And we haven't did these since the beginning of school because that's what we started with. It said identify any A values for which the expression is undefined. Oh, so basically you're going to, undefined means you get a 0 at the bottom. Remember, you can't have 0 in the denominator. So for instance, if I say 4 divided by 0, what do y'all think it is? Please don't say 0. 4 divided by 0, it says error. It says divide by 0. You cannot do it. And on some calculators even say domain error, because you cannot divide by 0. So basically what it's saying here, we want to know what values make this a 0 at the bottom. So what we're doing, we're going to look here and we're basically setting it equal to 0. But with that, you're basically saying, I got to factor this. I got to factor out like terms. So y'all remember factoring out like terms? So we can see here they both share A. So we're going to divide both of them by A. So we brought out an A. These A's are going to cancel out. Remember GCF, that's basically what we're looking at. And so it still leaves me with an A, because A squared divided by A is like you're saying, I have 2 A's on top and 1 A on bottom. So that still leaves me with 1 on top. Okay, so we're left with an A on top minus, okay, 7A divided by A. We mark out our A's, we're left with 7. Okay, so all we got to do once we factor is set each one of these equal to 0. So A cannot be 0. So 0 makes it undefined. And then also if we set A minus 7 equal to 0, all we're doing is solving for A. So we add 7 to both sides. So A cannot be positive 7. So those are your two undefined values that makes it undefined. So what does that mean? So basically, let me show what undefined means. So I got A squared minus 7A. Just want to show you. If I plug in 0 for A, watch what I get. So if I plug this in, I'm going to show you on my calculator. So we got parentheses. Oh, let me quit that. One quit. Enter. Okay, so if I do parentheses 0 squared minus 7 parentheses 0, I get 0. So remember, we want to know what value is going to make that a 0, because 0 cannot be in the denominator. Okay, so pause this video and try the rest of them. Okay, so we have rational functions here, and well, equations, because it has an equal sign. And so if the equal sign is in between it, remember we cross multiply. So I'm gonna draw my line through the equal. So I'm gonna come over here. We're gonna multiply. We put 2 here. Parentheses. We gotta multiply it. 4x plus 6. And then what we gotta do is distribute that 2 to everything. So 2 times 4x, that gives us an 8x. Then we do the 2 times the 6, that gives us a plus 12. Okay? Equals, now we're going to come over here on the other side. We're going to multiply x times x plus 4. So we got x times x plus 4. So we do x times x. So remember, when we're multiplying, we just add our exponent. So we have x to the second because it's 2 x's. Then x times 4 gives us a positive 4x. Okay? So remember our rule of thumb. We're trying to get like terms together. And so the only thing that I see that is a like term is this 8x and 4x. And remember, if x squared does not go away, that means everything has to go to him. So we're going to subtract 8x from this side. Whatever you do to one side, you got to do it to the other. But I can subtract it from the 4x because they're like terms. So I get 12 equals x squared. 4 minus 8 is negative 4x. Okay, so next we got to get this 12 to the other side by subtracting 12. We're getting everything to the other side. So here we just can't subtract it over here. We're just going to put it over here. Because 12 will not go with x squared, will not go with negative 4x. They're not like terms. So I get 0 here. 0 equals x squared minus 4x minus 12. And now, guys, we got to solve this. So just disregard the equal 0, all that. But if I just gave you x squared minus 4x minus 12, it should come to your mind that we're going to factor. So this is one of the harder ones because it has so many different steps to it. But remember, we come over here and do our A, B, C. A is the number in front of x squared. So there's no number there. So what number would it be? 1. It's always a 1. If you need to write that 1 there, put it. Okay? B is going to be the number in front of x. So the number in front of x is negative 4. And don't forget about the signs. Negative 4. In front of C, C is always a number by itself. It's going to be negative 12. Okay? So then we come over here, and we're going to factor our C. So we just number 1 through 9. And we get our calculator. Sorry. And we're going to find the factors of 12. So we do 12 divided by 1. And we get 12. So we do 1 and 12. I'm sorry, this keeps going away. Then we do 12 divided by 2. And we get 6. Then we do 12 divided by 3. And we get 4. Then we do 12. Sorry, wrong one. 12 divided by 4. And we get 3. We do 12 divided by 5. And we're going to hit a snag. So we got a decimal. So if we get a decimal, we automatically cross it out. Okay? Then we do 12 divided by 6. We get 2. 12 divided by 7. I'm going to do these quickly. We're going to get a decimal. 12 divided by 8. We're going to get a decimal. So anything with a decimal, 7 and 8 we can cross out. And then we do 12 divided by 9, and we should get a decimal again. So we can cross that one out. Now, remember, we can also cross out any repeaters. Repeaters is like if I say your name, if I say Mrs. Rucker, Rucker Miss, it's still Mrs. Rucker. I just reversed it. So we're looking for any repeaters. Do I have another 1 and 12 or 12 and 1? No. What about a 2 and 6 and a 6 and 2? Yes, so I always just mark out the second one. What about 3 and 4 or 4 and 3? Yes. Okay, so that leaves me with 3 possible answers. So remember, I'm looking for that one that's going to give me that -4. So let's look at this. If I add 1 and 12, I get 13. If I subtract 1 from 12, I get 11. So I can't get a 4 no kind of way with 1 and 12. But what about 2 and 6? If I add 2 and 6, I get 8. What if I subtract 2 from 6? I get 4. So 2 and 6 is going to be my answer. But now I need to figure out my signs. So I come and do plus, plus, minus, minus, plus, minus, minus, plus. So I have 2 all the way down and 6 all the way down. And remember, I need the one that's going to give me that -4. So 2 plus 6 is 8. -2 minus 6 is -8. 2 minus 6 is -4. So my answer would be this one. So let me show you how we're going to write this. So remember, we have that equal 0 here for part of our answer. So if we look back, I'll show you. Right here we have that equal 0. So we're just going to bring that equal 0 down, because all of this is going to be replaced with what we found here. So we got x plus 2, and all I got that is from my answer. I just put the x in front of the plus 2, and then the x minus 6. And our last and final step, because it's equal to 0, we basically got to set each one of these equal to 0. So x plus 2 equals 0, x minus 6 equals 0, and this does take a lot of room. So we just basically solve for x minus 2 from both sides. We get x equals -2, and then add 6 to both sides here. We do the inverse. You get x equals 6. So our 2 answers is x equals -2, x equals 6. So you can watch this part over and over to get and see what I did, but try the next ones by pausing this video and work them out. Okay, the next problem I want to do is, it says consider this complex number, and it says -5 minus square root of -64. And all it wants us to do is write the numbers complex conjugate in standard form. Okay, so the first thing we need to do is go ahead and work this part here. What's the square root of -64? Well, I should have pulled this up, sorry. But we need our perfect squares. I think it's here. Yeah, let me use this one. I'm going to copy this, because these are not hard at all. So if I paste that there, I'm looking for the square root of -64. Well, I'll see the square root of 64 here. It is 8. So I know this is going to become 8. But what about that negative? You remember what we did with that negative? The negative changes into an I. So I basically changed that to show 8i. So basically what I did first is I looked down there and see, or you can put in your calculator. You can do the square root of, if you tried to do the square root of negative 64, it would give you an error. So let me show you. So if we do second square root, let me pull this up some, of negative 64. So see, it won't let me do it. So another way, let me quit that. If I just did the second square root of 64, there's my 8 that way too. So either way you want to do it. And then the negative just changed it to an I. Okay? It doesn't change to a positive. It just changes to an I. Okay? So now it says write the numbers complex conjugate. So conjugate basically just means to change this sign, whatever it is. If it's positive, you change it negative. If it's negative, you change it positive. So this was a negative, so it changes to positive. And then the negative 5 comes down. So our complex conjugate is negative 5 plus 8i. So first step here is to break that perfect square down and go from there. So pause the video and try the other ones. Okay, so the next one we're going to do is some more logs. So this one basically, remember we take our little loopy-loop. We go from x to the second. So x is now big, 2 is now small. We go over the equals, so we're going to put our equals there. Equals 169. So there are several ways we can do this. We can either look on our roots paper and figure out what number to the second power equals 169, or a quick way to also do it is with our calculators. Let me move it over. So, what did that do? So basically, what this is saying, if I'm trying to solve for this, if I'm trying to solve for x, I gotta get x by itself. So the only thing with x is this 2 is squared. So I square root it to undo the square. So whatever I do to one side, I do to the other. So we can take the square root, second square root of 169, and we get 13. So x equals 13. So 13 times 13, or 13 to the second. So let me show you. So 13, just to check it, to the second should give us 169. There we go. Okay, so let's try one more. Let's try the one at the bottom. So x to the third. So x is big, 3 is small. Then we're going to go across back from 3 equals 512. And that's how you read these. So you can either use your roots paper that you have, your powers, whatever we want to call it, or you can use simple math. So we're trying to solve for x, so we got to get rid of this 3. So before we had to get rid of the 2 by squaring it, but to undo a cube root, okay, so the simple way to do this is to basically, you remember we did the square root, this time we're going to do the cube root, because that's the only way to get rid of cubing something. So we take the cube root of both sides, that undoes that, and we do it to the other side. So all we have to do is put in our calculator the cube root of 512. So let me pull up my calculator again and show you. So we go to the math button, and then you see this fourth button here. We can either use the arrow key and go down, and it comes up that way, and we do 512, and we get 8. So 8 to the third, let me show you. So basically 8 caret key to the third should give us 512. There we go. So that's another way of checking it. So now go ahead and complete the rest of them. So pause the video. Okay. Okay, so the next one is number 7. So once again, we're going to do our little loopy-loop. 6 to the x, 6 to the x equals 36. Okay, so we go to the 6's, and we're looking for what 6 to what power gives us 36. So we're just coming over here, and you see we got 36. So it's 6 to the second is going to give us 36. So 6 to the second. So x will be 2. Okay, so let's try this one. So we can do the loopy-loop, 2 to x equals, so we're going to go over the equals to 256. So now we got to figure out 2 to what power gives us 256. So we got to go to the column with the 2's. So we're looking for 256. And look, we have 2 to the 8 equals 256. And 8 will be our answer. So pause the video and complete the rest of them. Okay, so our next problem, it says the cube root of x minus 18 equals negative 2. So our whole goal in here is to solve for x. So I'm going to put my line through the equals like always. And if we have a square root, a cube root, fourth root, whatever, and it's isolated, we want to get rid of it. And so to get rid of the cube root, all we do is cube it. Okay? And remember, whatever we do to one side, we have to do to the other. So we have to cube root this side. Okay? So cubing this takes all this away, undoes it. And you're left with just what's underneath the radical. X minus 18 equals, and then you can put this in your calculator. Let me show you how you're going to put this in your calculator. Let me pull this up. Wait 1 second. Okay, so we got parentheses. Make sure you use parentheses because it's very important when it's a negative to the third. And we get negative 8. Now this looks like a simple problem. All we got to do is get x by itself. So to get x by itself, we got to get rid of this negative 18. We do the inverse, which will be add 18 to both sides. This goes away. And then we just figure out what this is. So we put in our calculator, negative 8 plus 18. And we get 10. So x equals 10. And guys, I can plug this back into my calculator and it should equal the same thing. So if I know x is 10, so let me show you what that means. So if I go to my math key and I go down to the cube root, and I know it was, I should have put 3, sorry. Kind of put the wrong one in there, but it's okay. The cube root of 10 minus 18, and I should get that negative 2. So I know I'm right because it equals what it said it should equal. The cube root of x minus 18 should equal negative 2. So when I plugged in 10, I got negative 2. Okay, so pause the video and try the rest of the problems. Okay, the next one says a set of test scores has a mean value of 8 with a standard deviation of 2. Which value has a z-score of 1? So I gave us our formula, z-score equals x, and x is just your data that's given to you minus your mean over your standard deviation. Okay, so what all you have to do with these is just take each one of these and figure out which one is going to give you an answer of 1. So our data, our first data point is 12 minus our mean. We had a mean of 8. I'm going to put parentheses here over our standard deviation of 2. So I'm going to put this in my calculator. 12 minus 8 parentheses divided by 2 and I get 2. So that one did not work. Okay, let's try the next one. We'll do 10 for our data minus the mean. Remember the mean here is 8 over 2. So we got 10 minus 8 divided by 2. And what do we have here? We have 1. So our answer to this would be our B, 10. 10 makes a z-score of 1. Okay, so pause the video and try the next problem.